Welcome back to the Algebra 2 series. Today we're going to be looking at this rational roots of polynomials example, where first I'm going to factor it, and then we'll work through using synthetic division. So we've done this before with a cubic, but for today let's just take note here that we have an x to the fourth and no x cubed term. So we're going to, again, look for maybe a difference of squares to work into this. And for this example, I'm going to choose a 4, x to the fourth minus 4x squared. And the reason I'm doing that is because I noticed that the remainder would be 2x squared, and that 2x squared seems to fit very nicely with the 8x plus 24. If I look ahead just one step, x squared quantity x squared minus 4. And over in the second part, I'm going to factor out a negative 2 out of this. But again, it only takes one step here um, to notice that the x squared plus 4x plus minus 12 and the x squared minus 4 will both have a factor of x minus 2. So factoring this as a continuation, we end up with x plus 2 and an x minus 2. Here we have an x plus 6 and an x minus 2, which now has our common term. We'll take that out front, and what's left over is the x squared times the x plus 2, or x cubed plus 2x squared. And then this last part here is going to be minus 2x minus 12. Now, of course, we could handle this by synthetic division if we wanted to. It's an easier number. It has a 12 at the end rather than a 24. However, there's also a way to work this out, and again, it involves the difference of squares. Of course, you can just maybe test one time, and if it doesn't work, then go ahead with the synthetic division. But one of the ways we can do that is to take your x cubed and your x term and create, again, a difference of squares. And just for fun here, we're going to try it again with the x squared, x cubed minus 4x. And if I take a look at that one, then what is left over here is going to be 2x squared. In order to replace the 2x from above, I'll have to add a 2x in, minus 12. And just by inspection again, we're going to see that this is going to have an x squared minus 4. And in the second part, plus 2. And this becomes x squared plus x, and this is minus 6. Now, notice when we work this out, that again, we see that x squared minus 4 and x squared plus x minus 6 contain, in this case, an x minus 2 again. So this is an x minus 2, and then we've got an x minus 2, and an x plus 2, plus 2. Here's the x plus 3 times x minus 2. Now, for some people, you'll be able to see this better than others. You're going to be able to see it. Others might have to do more trial and error. So perhaps the synthetic division will work better. Factoring out the x minus 2, we end up with an x minus 2 quantity squared here now. And combining the x with the x plus 2, that gives us x squared plus 2x. And in the last part, we get plus 2x more and a 6 remaining. That's equal to 0. Finally, we end up with this as our solution. I believe the x squared plus 4x plus 6 is going to have only complex solutions here, and that's because the b squared minus 4ac is going to be less than 0. That's a 4 there. And because of that, we're going to have a complex solution here, and so our only real solution will be 2. I'm going to just stop the problem right about here. Well, if we go back to this example and we start again, we're going to notice that the 24 has many factors that we could try. It's 1, 2, 3, 4, 6, 8, 12, 24. That's a lot of factors to be trying in synthetic division. And obviously we would want to have some sort of rule that would help us to work this out. Let's start by putting in our coefficients. We're missing the x cubed term, so we'll put in a 0 there. Minus 6, minus 8, plus 24. And then leave a little gap. Of course, our desire is to get a 0 right here. We're going to put a little happy face. Well, if we didn't know that 2 was an answer, we wouldn't really know where to start here. but obviously we've seen some clues. One of the clues is that if the coefficients all add to 0, then the number 1 will work, and in this case it does not. If you add up the 5 values, you do not get 0. Instead, you get a positive remainder. So I put a little plus over the 1. You can't even manipulate these to make 0, so I'm going to put an X underneath the 1. That's meaning the negative 1 doesn't work either. But let's just test another value. Let's try something like negative 3 and see what happens. In this case, I bring the 1 down, and I multiply. That gives me the negative 3. This is negative 3, and then I multiply again for 9. This brings down as a 3, and then I multiply again for negative 9, or negative 17. And of course, this becoming a 51 here, is that right? Yeah, 51, gives me a big positive number. I'm just going to put a plus right here. And what we see is that there's an alternation here in the quotient. 1, negative 3, then negative 17, and then a positive number. And what we learned from this is that if that's the case, and negative 3 does not work, it produces a positive answer, then none of the negative numbers that are less than negative 3 will work either. So I'll just write a no right there. So perhaps negative 2 could work. I'll put a box right around that one. And some of these positive values could work. But when we see this alternation, like we do right here, when you see that alternation, you know then that no value less than negative 3 will work. Well, of course, we've made a bit of a mess here, so I'll try to take all of this out. And I'm going to start again with a different value in my divisor box. This time we'll try a positive number, and we already know the answer is 2, so I'm going to just show you a little something on the number 3. Here you bring the 3 in there. 1, this is a 3, 3, this is a 9, 3, this is a 9, this is a 1, and this is a 3. I hope I did that right. I kind of went fast. Notice again, plus, 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 and plus. So we see that doesn't work, produces a plus, and that also means that none of these positive values greater than 3 will work because they will just basically explode. As we work through larger numbers, we're going to see that these numbers here continue to get larger and larger and larger. Okay, to make a long story short, let's finish this out by using the correct value, which is 2. And in this case, we're not stumbling upon 2. We're actually doing this by some deduction here after checking the 3 and numbers beyond. So putting in a 2 here, end up with the 1 here. This is a 2, and that's a 4. Negative 2, negative 4, negative 12, and negative 24 produces our happy face right there. That's the 0 we were looking for. Well, the nice part about this is now we can continue this by putting another value. This next part, after you have a 0 remainder, now we have left for us a cubic, and that cubic has a 12 right here as our last number. Now, if something didn't work up here, then it's not going to work down here as well. But we can try a 2 again. 1, in this case 2, this is going to produce a 4, 8, that'll be a 6, and then 12, and again we come out with 0. And as we finish out the problem by synthetic division, we see that x minus 2 occurred twice, and we're left with these values here, x squared plus 4x plus 6, the same thing that we had at the end of the last problem, where we work that through and find out that those guys are complex. And we'll stop this right here and move on in the next video.